Perhaps the most compelling moon or satellite in the outer solar system, perhaps in the whole solar system, is Titan, the large moon of Saturn. Titan is one of the largest moons in the solar system, and it has an atmosphere thicker than the air we're breathing, and made mostly of the same substance, nitrogen. There is no oxygen, however. The pressure of the Titan atmosphere at its surface is twice that of the air we're breathing right now. We've seen this moon up close, thanks to the Huygens lander, which was launched from Cassini in 2005, settled on the surface, and took about an hour's worth of data before expiring. We can follow the Huygens landing using actual video shot from the spacecraft as it descended through the smoggy murk of the Titan atmosphere. If we look at images of Titan, it's strikingly Earth-like. We see bodies of liquid, we see shorelines, we see clouds, we see rivers, dendritic channels, river deltas, runoff. It's an amazingly Earth-like view, but this place is utterly unlike the Earth. Water cannot be liquid on the surface of Titan, it's far too cold. All the speculation currently centers on oceans or seas made of a mixture of ethane and methane, with perhaps small amounts of liquid water and ammonia. This strange chemical brew could be the host of biochemistry, but if there's life on Titan, it will be life 2.0, utterly unlike life on Earth. At the moment, we have no idea if Titan does or could harbor life. It's even difficult to simulate in a terrestrial laboratory what might be going on in this strange material at the Titan surface. But this is a dynamic world where below these seas there is cryovolcanism, energy sources from deep volcanoes which actually heat that liquid to a tepid temperature, almost room temperature. A few years ago, NASA released an incredible image, light glinting off the surface of one of the polar region lakes on Titan. The first time we've ever seen light glinting off the surface of liquid on any other body other than the Earth. The Titan lakes have been mapped by Cassini using radar, and this detailed information fleshes out a picture of these as terrestrial worlds with all the features we'd expect to see in terrestrial topography.
Titan is the only planetary body besides Earth that we know has lakes. At 290 degrees Fahrenheit below zero, the only liquid that makes sense there is a combination of methane and ethane. This lake is Ontario Locus in Titan's southern hemisphere. It's a little smaller than Lake Michigan. We've colored the lake black because we think that's probably its real color, although we don't really know for sure. We've exaggerated the heights of the shoreline features to make them easier to see. Notice these hills, probably made of water ice. See how the liquid has flooded up the valleys? Further north is a long, smoother beach that looks like it's been shaped by waves. You can see some lines along the beach that might be old shorelines, like bathtub rings, so we know the level of the lake has changed. Now we're turning east to a very obvious bay that cuts into the beach, so it's likely to be younger. We'll cross over the lake, you'll see some flooded valleys, and in the background is a large river that makes a delta, like the Mississippi River. Its shape means the lake is shallow and the river is slow. Ontario's shore is surprisingly like earthly lake shores. Pretty amazing to find something this Earth-like 800 million miles away.
Titan may be the most compelling target in the solar system for future detailed exploration. After all, we only got a quick look at its surface from a lander that sent back a small amount of data, but we've known of a few other places which also deserve a second look. In particular, the water worlds. One of the most fascinating worlds in the outer solar system is Saturn's large moon Titan. Studied up close by Cassini, and with a visit from the Huygens lander in 2005, Titan has an atmosphere twice as thick as the air we're breathing and made of mostly the same stuff, nitrogen. It also has bodies of liquid all over it, made not however of water, but of ethane and methane, perhaps mixed with a little water and ammonia. This exotic chemical brew could potentially contain biochemistry utterly unlike life on Earth. It would indeed be life 2.0.